Sorry. So yesterday we saw about the views and also so what we discussed just views, yeah.
Views yesterday.
Okay.
And
Okay. So we discussed views and the limitations and advantages of views. Okay.
yeah,
So today we discussed the indexes.
indexes.
Okay. So yesterday we tried to update the result set. Okay. So that we got by combining two or more tables, right? So we
Okay, yeah.
can't able to update the data, okay, update the
Hmm.
result in the view when
Hmm.
uh, when the result is by combining two or more tables. Okay. So I think I already have shown that. Just a second. I'll show it again. Okay. See here, actually, yesterday we tried. Uh, is this the table? Okay. I think I changed the tables here. Okay. So actually,
Okay.
uh, when we are trying to update the data, okay, so it won't update actual data. Okay. So we make it some errors there. Okay. So we will see at that instead of triggers. Okay. The trigger concept again we will see the view complex views. Okay. So we
Okay.
discuss the complex views neatly, and so instead of using views, we can go for the triggers. Okay, we discussed that concept and the trigger concept. Okay, and today indexes. So what is an index? Generally, so any idea what is an index?
Mm. Means if we want to, whatever data we have stored inside,
Yeah.
like the front page, which
Yes.
inside any book or something, which indexes are there. The same way in database also it is there.
Yeah. Exactly. Okay.
If you
So
want to
here.
search any record, yeah,
Mhm.
very quickly,
Yes.
then we can use index.
Yes. Exactly. So same thing like index. Okay. The textbook we have an index page. Okay.
Yeah.
In that index page, you'll find the concepts. Okay. The chapters and also the
Yeah.
topics and the page number. Right? So you can go directly, you can go for the page number. Okay, you can for the
Mm.
particular concept. So no need to search
Mm.
every page. The same thing
Okay.
we are implementing in the database, in the table.
Okay.
Okay, so that is indexes here.
Mm.
Here we have two types of index: clustered index and non-clustered index. Okay, so clustered index means um, yeah, just a second. Yeah. So clustered index means it determines the physical order of data. Okay, that means if you are having the data in the let us consider the book. Okay, so if you are having the concept in 29th page, okay,
Mm.
so the 29th page will be stored in the cluster index.
Okay.
Okay, directly we can go for the data, the physical data. Okay, so that is the cluster index. Whereas the
Mm.
non-cluster index, it saves the pointers. Okay, so it
Okay.
saves the pointers and the pointers indicates the physical storage of the data.
Mm.
Okay, so it helps, the pointers helps us to find the physical storage of the data. So that is the
Okay.
non-clustered index. Okay, and we can have only one cluster index in the table. For the table
Mm.
we can have only one cluster index, but for that one clustered index we can take multiple columns.
Multiple columns.
Okay, that is composite key, we can call it as a composite key.
Composite key.
Okay,
Okay.
so the same thing we have in the primary key also. So we can take multiple columns for the primary key, but you cannot have multiple primary keys in a table. Okay, that is the difference. Okay, we cannot have multiple primary keys in the table, but we can give multiple columns for a single primary key constraint.
Okay.
Okay, that we call as a composite. Just give us a lot of noise. Sorry, every day I'm having a problem. Same session. Yeah. Okay. So let us take a index here. So index, these are used by the queries to find the data from tables, okay, quickly. So we can find the data quickly from the table, okay, so by the queries. So indexes, we can create index on the tables and views. On both the tables and views, we can create the indexes, okay.
Yeah.
Let's try to take the data. Used by queries. Today we try to discuss normalization as well as how to create schemas also, okay? I think
Okay.
yesterday you asked that, right? So
Yeah.
we try to discuss that thing also. Okay, so that's it. So we can create indexes. So actually, when you are defining the primary key, okay, so automatically you will get a clustered index. Okay,
Okay.
so let's see that. Do you have any primary key? Okay, I will show you that. Okay, so when we are defining primary key for any column, so automatically a clustered index will be generated for that table. Okay, so if
Okay.
not, okay, we can, if there is no clustered index, we can create that manually. Okay, let's see that. So there are two types of indexes, that is,
Clustered and non-clustered.
yeah, clustered index. Okay, and the clustered index determines the physical order of data in the table.
Okay.
Okay, so and the non-clustered index, it will we used to have pointers. Okay, we used to have pointers, and these pointers helps us to find the physical data. Okay,
Okay.
that is the cluster index, non-cluster index. Let's try to create a cluster index. Okay? So create. So index is one of the database objects, right? So to define class index, you need to use create command. Create.
Okay.
Okay. So we try to create cluster index on employee table. So create cluster index and just give the name. Okay. Index. Okay. Index name. Create cluster index. Otherwise,
Okay.
you can create just index. Let's see. I'm not giving clustered here. Let's see. Create index name on table employee. Okay. For which column? I want to create index for the employee. Okay. So that's it. Okay, let's see that. Execute the command. Done. So here you find indexes folder, right? So go to that index folder. See that. Okay. So when you are defining, okay, just index. Okay. So we'll get non-unique, non-cluster index.
Okay.
Okay. So when we are defining only, yeah, when we are taking only index, so we will get a non-unique,
Non-cluster.
non-cluster index. Okay.
Okay.
So to get the cluster index, either we have to assign primary key constraint, otherwise directly assign the non-cluster cluster index. Okay.
Okay.
So let's try to do that. Let me drop it. So how to drop?
Dot index.
Is it the way? So must specify the table name and index name for the job index name. Okay. So because index is a property of table, right?
Yeah.
Just a second. I will tell you the command. Actually, something here. I will let you know that command. So here, so let me assign a constraint. Okay, primary key constraint. Let's see that. Alter table employee and constraint. So constraint name. I think you remembered this thing, right? So first we need to convert that into mock, then we need to assign the primary. Okay, so now let's see that. So I got the primary key here, and go to the index. You can see that. So I got the cluster index also. Okay, that is, this is a cluster index. Okay, so not unique, non-unique. Okay, nothing there. Okay, just a cluster index. So whenever you define the primary key, automatically you will get a cluster index here. So what is the purpose of a cluster index? Okay, actually the index will arrange data in a particular order. Okay, so for example, I have a data like I have a salary. Okay, the columns, the column salary column, I have the values like 34,000, 15,000, 70,000, 24,000, and something like that. Okay, some random numbers. Okay, so when I assign cluster, when I assign index on any column and the salary column or any other column, okay, it will arrange the data in particular order. That means in ascending order. Okay, because the default is ascending. Okay, it will arrange the data in ascending order. So because if we have the data in a particular order, it is easy for us to fetch the data. Okay, to drag the data. So if my condition is like taking a condition like this. Okay, select staff from employee where salary is equal to where salary is between 50,000 and 75,000. Okay, so my query is something like select staff from employee where salary is between 45,000 and 75,000. That means between 45 and 70. Okay, so when we don't have the cluster, okay, when we don't have the indexes, it will search, okay, it will search every record from first record to last record if you don't have the index. Okay, but if you have the index, or otherwise if you have the primary keys, okay, it will likely go to the particular range. Okay, something like 45. So directly go to the 45,000 and fetch the data 45 to 75. Okay, so the fetching, okay, the retrieving is quick here. Okay, the dragging of data from the table is very quick here because we are arranging the data in a particular manner, either ascending order or a descending order. Okay, the index, giving index means we are arranging the data in a particular order. That's okay, so that it is easy for us to fetch the data, to retrieve the data quickly. Okay, so that is the thing here. So let me show. Let's take that. Okay, let's take an example. I'm dropping the cluster index. Okay, so I dropped the primary key, so automatically the index got deleted. Okay, here now I don't have any data, any indexes here. Let's see the data. Select staff from employee. See here, it is not arranged in a proper order, right? So check it out.
Yeah.
Okay, it is having some random values. Now, let me create index for this. Okay, so create index, otherwise clustered index on employee table of employee. Otherwise, let me like salary. Okay, so here I'm using a composite.
Hmm.
Okay, okay, so I'm using a composite key. So that means I'm assigning clustered index two columns on two columns.
Oh,
Okay, now let's see.
okay.
So create index. Okay, now refresh the indexes here. So you see here you will get one index. Okay,
Hmm.
but this index we are having this index on the two columns, employee and salary. Now let's try
And
to.
salary.
Okay, so actually arranging the data in an employee. Okay, so let me try to drop this index. Okay, now check it out. Okay,
Hmm.
I define clustered index on the salary column. Okay,
Okay.
see the order now. It is in the ascending
Yeah.
order.
Hmm.
Okay, so like this. So if you want to take descending order, you can give that. Okay, near salary. Okay, provide the
Hmm.
order here, descending, like this.
Okay.
Okay, the index will arrange the data in a proper order, either in a ascending or descending order. Okay, so
Hmm.
same thing like order by clause. Okay, so that is the indexes list. So it helps us to find the data very easily. That's it. Okay, so this is about the
Okay, so
cluster.
this
Yeah, tell me.
you have written create clustered index then on table.
Pardon me, I didn't got you.
Uh, Means what is the syntax for this
Yeah.
create clustered
So
index?
create clustered index name. Okay. For
Index name.
for
Okay.
every property, you need to give the index name. So constraint name,
Okay.
index name. Okay. Trigger name, stored
On
procedure name.
table.
Yeah.
Table name.
Table name also. Everything you need to give the name. So create cluster
Okay.
index name on table. On which table you are assigning. Okay.
Hmm.
Giving the index. Okay. Take the table
Okay.
and the column.
Yeah.
Okay. So that's it. So actually, the statement has to work. To drop the index, the statement has to work, but I will check the error. Okay, I will check the error and I will let you know
Okay.
that.
Yeah.
Actually, we don't use these all these indexes and everything in very basic way. And even an MSBI developer, they don't go for creating tables. Okay, designing tables.
Okay.
So the administrator will design the tables and he will give the tables to you. Okay, so according to that, you need to process the data. That's it. So our work is to process the data. Okay, so all this is to for the interview sake only. Okay,
Okay.
right. So this is about the cluster index, and let me create non-cluster. So what is a non-cluster? Yeah. So what is a non-cluster
Non
index?
plus. No idea.
Okay. So actually, simple. So the data will be in one place. Okay, but the index will be another place.
Okay.
Okay. So that means the index will act as a pointer here.
Mm-hmm.
Okay, so by cluster index, okay, we can able to find the data, we can able to um, get the data directly. Okay, we can able to fetch the physical data, but by non-clustered index it won't take us to the actual data. Okay,
Okay.
so it creates, okay, it will act as a pointer to the data.
Mm-hmm.
So from one pointer to another point to another, at last it reaches the physical data, like a hierarchy. Okay, I think you know the hierarchy. Okay,
Yeah.
so like a tree diagram. Okay, it has
Mm-hmm.
the pointers, and at last in the down it will find the physical data. Okay, that means non-clustered index doesn't have the physical data. it only it only have the pointers. Okay, we can say
Pointers.
pointer to the physical data. That's it. Okay, so you can have any n number of non-clustered index in a table, but
Okay.
you have only one clustered index, like a
Mm-hmm.
primary key. Okay,
Okay.
so whenever you want to create another cluster index, you can't able to do that. Okay, but you can apply the same clustered index on multiple columns, like a composite tree. Okay, so that's the concept here. So um, that's about the non-cluster index. Let's try to define it. Create non-cluster. I think it's not to define index. Okay, automatically we'll get the non-cluster only. So index. So index name. Okay, on employee. On which column? Let me take the gender.
Sorry.
Whatever it is. Okay, you can take any column. You can create index on any column. Okay, so that's it. So like this, you can create n number of non-cluster index on the columns on the in a table. Okay. Now there is another concept. There is another index called unique index. Okay. So we have a unique index. So unique index, cluster index, non-cluster index, and also non-unique. So non-unique, you check it out. Okay. Now let's go to the
So what result will come for this? For non-clustered index?
non-clustered means just it will act as a pointers. Okay. So
Yeah, that I know. But okay, when you run it, what kind of table will come? Just run it once.
I didn't got it actually. What kind of table means?
And what result will we get?
So cluster index means we don't get any result. Okay, just
Oh,
we
we don't.
we are arranging the data. That's it. Okay,
Okay, okay. Get it.
interiorly we are arranging the data.
Hmm.
So it helps us to find the data quickly. That's it. Okay, so we don't retrieve
Okay.
any data. So to retrieve the data, we need to select this employee. Okay, but
Okay.
the time consuming will get less here. Okay,
Hmm.
that's it. So we can't show the output of a cluster index and non-cluster index. Just we can able
Okay.
to see the structures. That's it. Okay.
Hmm.
So when you are handling some lakhs of records, some crores of records, at the time you can observe the difference without index and
Okay.
with index. Okay.
Yeah.
That's it. So here and non-cluster index. Just we got the syntax and the unique index. Okay, we have a unique index here. You can check it out.
Mm-hmm.
When I'm creating a index here, non-cluster index, automatically I'm getting a non-unique. So what is the meant by unique and non-unique? So generally,
Unique means something particular value is the unique value
yeah.
or
So
unique record.
yes. So it will check the uniqueness of the column. The
Yeah.
same thing like unique key constraint.
Hmm.
Okay. Constraint and index are both are similar. Okay, so unique key constraint, what you do, its functionality is to check the uniqueness of the column. That means it won't allow the duplicate records. Okay,
Okay.
non-clustered means in this non-clustered column, okay, non-clustered index column, we can have the duplicate records. Okay, we can have the duplicate values, but coming to the
Okay.
clustered index, okay, in the
Hmm.
clustered index we can't have the duplicate values. Okay, is it clear? And that is
Yeah.
unique. That is unique cluster index. Okay, if it is a unique cluster index, it won't accept the duplicate records. So that is the difference here.
Okay.
Okay, so now check it out. How to what is a unique cluster index? Unique index, it is used to enforce uniqueness of key values in index. Okay,
Hmm.
so let me. So I'm dropping this index, non-cluster index. So here
Hmm.
I'm taking a unique. Okay, so create unique. Okay, Index name. So today nothing going good today. So check the error. So what is the error here?
One your duplicate has been terminated.
So create unique index statement terminated because a duplicate key was found for the object name employee. Okay. So the duplicate key value is something. Okay. What is the error?
Duplicate key values.
I shown this at in the primary key also. Okay. So we got same error when we are assigning a primary key.
Is it not taking a unique value?
Why we are not able to assign unique uh, index on the gender column?
Duplicate key values.
Simple. We
There
have the
are.
data. Okay. There is a duplicate record in the gender column. Okay. Because of the duplicate data, we are not able to assign the property. Okay. Simple.
Okay.
Check it out. Select staff from employee. Okay. See there. There is a duplicate record,
Yeah.
correct? So that's why you are not able to assign unique index on the gender column. Okay. Now try to take that unique index on the. Can we take on name?
Name. Yeah.
Okay. Because there is no duplicate values. So command complete successfully. Try to refresh the index. You will get the unique non-clustered. Okay. Earlier we got the non-unique cluster, non-clustered, but now we got the unique non-clustered. Can we have the unique clustered?
Unique cluster.
Yeah.
No, you can have.
What is the reason?
No.
So what's the reason?
Same error will come. There is unique value will not be there.
Let me delete the unique non-cluster index. Okay. So now I want to create unique clustered index.
Okay.
Okay. Is it possible?
You cannot create more than one cluster index on table.
Okay. Let me delete this one also.
Yeah.
Okay. Now. See here. Refresh the index. That's it. Okay. So clustered index and the unique cluster index both are similar. Okay. Uniqueness means what is the clustered index? Okay. When we get the cluster index, when we are assigning primary key on the primary key constraint on for a column, we get the cluster index automatically. Okay. So that means primary key means it won't allow the duplicate values, right? It also checks the uniqueness. Okay. So we can have the clustered index on the unique cluster index on the column. Okay. So unique cluster index, cluster index both are similar. But it can change for index, non-cluster index, and you can have the non-unique and the unique. Non-unique means it will allow, the non-cluster index will allow the duplicate records. And if you want the unique values, so you need to convert that into unique non-cluster. Okay. So here index concept is very simple. That's it. Okay. Syntaxes. We need to add syntaxes. That's it. We don't have anything here. Okay. So just interiorly, okay, it will arrange the data in a proper order. Okay. To fetch the data very quickly. Okay. That's about
it. So unique clustered index is possible, but unique non-clustered index.
It is also possible.
It is also possible.
Okay. Unique. So see here, clustered index and unique cluster both are similar. No need to specify the unique. Okay. So that's what I'm saying. But you can specify unique, non-unique for the non-clustered index.
Okay.
Okay. So that's it. So actually the index, okay, normally the index will arrange the data in a particular order, at ascending order and descending order. That's it. Okay.
Okay.
So
Yeah.
same thing like order by clause. So this is about the indexes, and so
Figures.
so there is some limitations for the indexes also. Okay.
Okay.
So for cluster index, okay. So we are so what are we doing here? We are arranging the data. Okay. So when we assign the cluster index, okay, it needs the clustered index needs addition space, storage space. Okay,
Okay.
because it will arrange the data in to arrange data, it needs space, memory space. Okay, so that is the limitation. Clustered index needs the memory storage. Okay,
Okay.
even sorry, clustered index no need to have memory storage. Okay, but non-clustered index will needs memory space, because here clustered index directly points to the physical data. Okay, there is no
Okay.
intermediate there is no intermediate pointers for the clustered index, but for the non-clustered index there will be a lot of intermediate pointers here. Okay, so it won't save, okay, physical data in the non-clustered index. We won't have
Okay.
physical data in the non-clustered, but we will have the
Non-clustered index.
pointers. Okay, so that's why the non-clustered index needs extra space, extra memory space,
Okay.
but clustered index no doesn't need any extra
Extra
memory
space.
storage. Okay, so that is the advantage and limitation of a non-clustered index. And there is another limitation with the indexes. Okay, so if we assign index on the column in the table, okay, so when we're inserting the data, when we're updating the data, okay, when we're deleting the data, the performance will get slow. Okay, so we can't able to insert the data as fast as soon. Okay, so as we did without indexes. Okay, if we have the index, we can't able to insert the data uh, fastly, okay, quickly. So that is the
Quickly.
limitation of the indexes. Okay,
Okay.
because it has to search every condition. Okay, it have to search for every condition. That's why. So we can't able to insert, update, delete data quickly.
When they are in index.
Okay, if
Okay.
you have the indexes. So this is the index concept. Okay, if you have any questions, please go ahead.
No.
Okay, so
Clear.
simply, okay, so this interview question. So why we use indexes and what are the types of indexes? Can we have
Okay.
non-clustered index, multiple non-clustered index on the data, on the column? Okay, and how many cluster index we can assign?
And the single.
Okay, so like this. So that will be the
Okay.
interview question. Okay, so what is a
Yeah.
unique and non-unique non-cluster index? Okay, so these are the interview questions based on the indexes. And let's go for the schema. How to create a schema here? Okay,
Later on, you will give me the interview questions.
definitely. I will
Oh,
actually preparing a document here. Uh,
okay.
so so I'm creating some tables. Okay, some data here. You can check it out.
Okay.
So I
Yeah.
will send you almost 50 to 100 queries. Okay, just try it. Okay,
Okay.
based on this data, um, just preparing 100 to 100 queries. So I'm thinking about that. Okay, so let's see. So 50 or 100. Okay, I will
Okay.
send that queries to you. Okay. Uh, send coming to the interview questions. I will send it. Okay, no need to worry about that.
Okay. Yeah.
Right. So this is about the indexes, and let's see schemas. So what is a schema actually?
Schema.
Schema means relationship. Okay, so here RDBMS, Relational Database Management System. The total structure is based on the relationship among the tables. Okay, the schema gives the relationship among the tables. Okay, so let's see that how to create a schema here. So just simply create. Just a second. Create. schema. Just give the schema name here. Okay. Let's give some schema name as something like this. Okay.
અને કેવું છે કે ઇનસ્ટોર બી છે ને ઓનલાઈન બી છે તો હા હા ઓકે તો જોઈ લઈએ આપણે બાકી આઈકેના તમે
So check it out here. This is the syntax to create the schema. Create schema and the schema name. Okay. Here I'm giving schema name as EMP. Okay, some random name here. Okay. So in the database, that's it. Okay, let's go and check it out. Where you find the schema.
અલગ અલગ ટાઈપનું છે હા એટલે એમ જ ટાઈમ પાસ કરી
So in the security folder, okay, you will find users role schemas. Okay. So go to the schemas there. You will find these are all the systems now. Okay. And this is the user defined schema. Okay. So this is user defined schema. You can create a table on this. Just like.
હા હા ના એ બીએસડબલ્યુમાં તો છે ને કેવું છે કે 3 ફ્લોર છે આપણા અને મેઇન સેક્શનમાં આખો ફ્લોર છે બીએસડબલ્યુમાં હા 34 કે 36 કે 36 છે 7 થવાનું છે જોઈ રહ્યું છું ત્યાં મેં નાખી દઉં હા એ તો હું કરી દેવાનું છું અને ફ્રાઈડેના ક્લાસ પછી જ જઈશું હવે શીખીને વાત તો કરી છે પ્રાચીના ભેટથી ક્રૂઝનું હજી તો ડિસાઈડ નહીં કર્યું બધા કે જવું હોય તો જઈએ બાકી આદિત્ય એક બિલ લઈને આવ્યો 15 અલગમાં બીજી ક્રૂઝ છે અને તે તમને મેં કહી દીધું કે પ્રાચીને આપણે બધા $1 આપી દે મોર ભરીને એટલે બધાની ટિકિટ વસૂલ
Right.
પછી આ 15 અલગ જતા રહે
Let me try to create a table here by using the schema. Create and table with the schema name here. EMP. Dot. Okay. And just create a table here.
Yeah.
Employee ID. Here. See here, I already have a employee table, right? So I already have an employee table. Again, I'm creating an employee table here. Okay, is it possible? Generally, is it possible to create the same table?
No.
Okay, it's not possible. But here, I'm able to create the employee table again. So what is the difference here? Schema. Okay, so I change the schema name here. Okay, actually the schema name for the this employee table is DBO, but the schema name here is EMP. Okay, this is a user defined schema. Let me try to refresh this. Yeah. Where is that? Okay, you can check it out. emp.employee. Is it clear?
Yeah.
So you can we can have same the tables with the same
table but
different schemas. So this is how to create a schema. Okay, schema means so just we relate all the tables. Okay, we relate all the tables here in the schema. Okay, so this is how to define the schema. Okay, right. Now let's see the normalization forms. So what is the normalization? Any idea on that?
Normal, no.
Okay. So here normalization means actually we are using RDBMS, right? So we can't
Okay.
able to maintain the data in a single table, the total data. Okay. For example, if we consider employee data and the department table, okay.
Okay.
So if we maintain, okay, if we save employee data and department data on a single table, okay, we can't able to get the results exactly, okay, accurately. Okay, so normalization means it is the process of organizing the data, okay, organizing the data um, to what we say, okay, so it is the process of organizing the data to minimize data redundancy. Okay, so data redundancy means duplicate data. We can call it a duplicate data.
Duplicate data. Yeah.
Okay, so it is a process to minimize data redundancy.
Minimize.
Okay,
Okay.
so which ensures, okay, data consistency. Okay, so it ensures the data consistency. If we apply normalization on the tables on the data, okay, so we can have the consistent data. Okay, so let me show you the tables here. So without normalization, okay, it will be like this. Salary, and let me take department name. Okay, and what I'm doing, I'm taking total. I'm saving the department data and employee data on a single table. Okay, the
Okay.
department head. Okay, it's in this way. Now refresh the tables here. The data will be in this way. Okay, it will be like this. So here it's a lot of members. So a lot of employees are working under the department IT department. Okay, so for every employee we have to assign the department name. Okay, and we get the duplicate records also. Okay, and here this is without normalization. Okay, but there is no relationship between the employee data and department data. Okay, but
Okay.
we are saving the total data in a single table without any relationship. Okay, so
Okay.
when I want to drag the data, okay, when I want to drag the only employee data, so can I do that? Because we are having a relation, we are having some dependencies here, right?
Okay.
So depart IT Joseph, you say, okay, they are dependent on the total, uh,
Dependent on, yeah.
on the employed
Employee.
people. Okay, so when I want the just only employee details, okay, I can't able to get that. And here,
Okay.
so there will be, okay, there will be a lot of employees working under IT department, working in IT department. Okay, so for every employee we have to define the department name, and there
Okay.
will be duplicate records here. Okay, the memory space. Okay, it takes more memory space here. If the table structure is in this way, okay, it takes more memory space, and we get the data duplicate data. Okay, so lot of issues here. So without
Okay.
normalization, what are we doing here? We are organizing the data to minimize this duplication. Okay, data duplication. Okay, so by using normalization. So the limitations of without normalization. Okay, the limitations without normalization is it takes more disk space. Okay, and data inconsistency. The data is not consistent in the without normalization, and so DML queries. Okay, DML queries can become slow here. We can't implement the DML queries on this data. Okay, so that is the limitations without normalization. Okay, to overcome all these limitations, we have three normalization forms. Okay, the first normalization, second normalization, and third normalization. Actually, we have 6 normalizations, but we don't use all the 6. We just need only 3 normalization forms.
Only 3 normalization.
Okay, so let's see that. So nothing is going well today. I'm having a lot of issues at this time. Power cuts. A lot of issues at this session timing.
Okay.
So power cuts, network problem, and now. Okay.
It's raining.
But no, it's not
raining.
No, not raining actually. So here it is summer, but on the day it rained here. Okay, unexpected. On the summer it's raining. We don't know why it's happening like.
Which place are you from?
So first normalized form. Okay. And second normalized form. And the third normalized form. Okay. To limit all these restrictions, okay, to overcome all these limitations, we use this normalized form here.
Normalization.
And first normalized form means in this first normalized form, the data has to satisfy some conditions here. Okay. So the data in each column should be atomic. Okay, should be atomic means here we can't assign the data like this. Okay. Na, comma, yeah, comma, something. Okay, something like this. So we can't able to assign like this. Okay. So in a single column, multiple values. Okay. So we need to check this option, or we need to check this thing. The data in each column should be atomic. It should not be like this. Okay. So no multiple values separated by a comma. Okay. And that is the first condition. And the second condition in the normalized form is, first normalized form is, the table does not contain any repeating column groups. Okay. That means what we take here. Okay. So here we took the employee name, right? Okay. So, but it should not like it shouldn't be like employee name 1, employee name 2, employee name 3 like that. Okay. So that is a repeating columns here. Employee name 1, 2, 3 is a repeating column groups. Okay. It shouldn't be like that. So I want to show you. Okay. Employee ID, employee name 1. Okay. Employee name 2, employee name 3. It shouldn't be like this. Okay. The data. Let's keep the data. 100. Nag. Okay. Priya and something. Okay. And in the second record. Okay. It shouldn't be like this. But here we're having 3 columns. Okay. In the first record I'm having values for the 3 columns, but in the second record I'm not having the value for third column. Okay. So there is a waste of memory, right? Okay. It shouldn't be like this. So The second condition is the table does not contain any repeating column group.
Repeating column.
Okay, let's take the conditions here. So what is the first condition?
There
The
should not
first
be
condition
multiple.
is data in each column should be atomic. Okay, so no multiple values separated by column.
Okay.
Okay, so this is the first condition, and the second condition is the table does not contain any repeating column groups. Okay, the column should be unique. Okay, we should have different fields in a table, but it should not be repeating column groups. Okay, so these are the two conditions in the first normalized form. Okay, and we have another condition that is it should identify each record uniquely using primary key. Okay, so that is the third condition. Okay, every record should be identified by the primary key. Okay, so if we don't assign the primary key, we get the what we do, we have the duplicate records in each column, right? So we will get the duplicate records in each column. So to remove, okay, to limit the duplicate records, we have to assign the primary key. That is the third condition. So identify each record uniquely using primary key. That is the third condition here. Okay, this is the first normalized form. Is it clear?
Yeah.
Do you have any questions?
No.
Now let's come to the second normalized form. So what is the conditions in the second normalized form? The first condition is the table has to meet all conditions of first normalized form. Okay. The first primary condition is it has to meet all the conditions. Okay. It has to meet all the conditions of first normalized form. And then coming to the second, no, redundant data to separate table. That means, so check it out here. So there will be so there will be a lot of employees, okay, on the working in the IT department. So here, the department we get a lot of duplicates, right? So IT will be repeated around, it can be 10, 20, 30, okay, 30 times also, okay, because 30 employees. So if 30 employees are working in IT department, so for every employee we need to specify the IT value for the department column. Okay, so we are having duplicate records. So to reduce that, we have to move this redundant data to separate table. Okay, so we need to move this. Okay, we need to separate department details, and we need to save the details into another table. Okay, so in another table, it will be like this. If we move the data, okay, if we move the redundant data into another table, okay, it will be like this.
Information. Sorry, sir.
Okay, it will be like this.
Okay.
Okay, so here
Hello.
in the first, okay, in this first, without normalization, the IT value is repeated 30 or 40 times, more than 30 times. Okay,
Okay. Yes, sir.
if you're having employees working in
Statistical analysis.
30 employees working in the IT department. Okay,
Mm-hmm.
but now here, check it out. There is only unique values here: IT, sales, HR. Okay, so we are reducing the duplication by separating the data. By separating the data, we are reducing the data duplication. Okay, so that is the condition in the second normalized form. Okay, is it clear? If you have any confusion, let me know that. Okay,
Okay.
we'll try to discuss in detail.
Yeah.
So
The
nothing is there.
IBM
We are
analysis.
having IT
Yes,
values.
sir.
We are having duplicate IT values in the without normalization. Okay,
Mm-hmm.
but after normalization, okay, we need to separate. After
Separate.
second normalization, we need to separate the department data, and if we separate the department data, it will be like this.
Okay.
Okay, so now we can join the tables and we can retrieve the result whatever you want. Okay,
Mm-hmm.
so the retrieve, okay, the dragging of the data is very fast. If we separate the data and relate the table, okay, by using difference. That is department ID. That is the second condition in the second normalized form. Okay, move the relevant data to separate table. And then the third condition is create relationship between tables using foreign key. Okay, this is the third condition here. So we are separating the data, and to retrieve the data now, according to our requirement, we need to relate the table, right? So we give relationship among the table by using primary key and foreign key. Okay, so that is the third condition in the second normalized form. Okay, is it clear? If you have any questions, let me know that.
Yeah.
Now, so let's see the third normalized form. The first condition is it has to meet all the conditions of first normalized form and second normalized form. Okay, and the table shouldn't contain columns that are not fully dependent upon the primary key. Okay, for example, let's say uh, okay, just check it out here. Department name, department head, location. Okay, this data is not dependent on the employee ID.
Yeah.
Okay, it is a separate data. Okay, they are not depending on the primary key column. So we have to separate these non-dependencies from the table. Okay, we have to remove these non-dependencies from the table. So that is
Okay.
the condition in the third normalized form. Okay, so the
Okay.
table shouldn't contain columns that are not fully dependent on the primary key. Okay, so every table should have columns that depends on the primary only. Okay, every
Okay.
table should contain columns that depends on the primary key. The columns doesn't depend on the primary key. We have to separate that columns and we have to save that columns in another table. Okay,
Okay.
so that is the second. That is the last condition in the core normalized. So what is the first condition? So it has to meet. The table has to meet all the conditions first normalized form and second normalized form. And the second condition is table does not contain columns that are not fully dependent primary key column. Okay, that is the last condition. Okay, if any table satisfies all these conditions, okay, so we can able to retrieve the data as we require. According to our requirement, we can able to retrieve the data in an easy way. Okay, every table has to satisfy these conditions. Okay, the first normalized form, second normalized form, third normalized form.
Okay.
Okay, so this is about the normalization. Is it clear?
Yeah.
So if you have any questions, please go ahead.
No.
Right? So normalization is used to minimize the data redundancy. Okay, so that is very important. So to reduce the data redundancy, we are using all these conditions. Okay, right. So we discussed union and union, right?
Yeah. Yesterday we discussed.
Okay, and also we discussed stored procedure, right?
So procedure. Yeah. That also.
And we will discuss subqueries and
Is there any function like date add and date different?
yeah, we discussed it, right? Data function.
Date and it's same, right?
Pardon me? Yeah,
Date add and date different.
yeah, same thing.
Okay.
So in the data functions, we have year, date, month, and date path, date name, okay, date add,
Okay.
date
Yeah.
return.
Yeah.
Okay, these are all the functions under data function.
Then hint.
Pardon me?
Hint.
I didn't got you.
HINT. Hint.
Hint.
Yeah.
Uh, I I think it is in 2012 version. I need to check it out. Okay, I will check it out
Okay.
and let
No
you know.
problem. Yeah. Yeah.
If there is a hint, now I didn't listen it. Okay, I will check it out. Okay, because we are getting new versions, right? 2012. Now we are having a new version, 2014.
Yeah.
Okay,
Yeah.
let's see that. But we don't use all that functions. Let's see that. So
Okay.
if I find, I will tell you.
Okay. So you just check the. I yesterday also I tried the same problem is coming in backup.
Okay, okay, okay.
What to do? Of restore file. Some error is coming of
Um,
restore file.
I'm making you presenter. Please accept it.
Yeah.
Okay. So where you save the backup files?
Yeah. One more time. So it's not opening. I stored it in this. It should be dot .bak, right? Extension.
Pardon me? Extension should be BAK. Yeah,
BAK. Yeah.
backup file.
So I stored it over here. Here this one. Adventure work
Okay,
dot .bak, right?
right. Go to the database.
And one is this Adventure Works DW 2008 R2. What is that?
So that is data warehouse.
So I have to back up this one,
Yeah,
Adventure Works
yeah,
dot .bak.
both database and data warehouse. Okay, so we use
Okay.
both the databases for reporting service.
Mm-hmm.
So nothing is there.
Taken a long time.
So data warehouse means we separate all the numerical columns and non-numerical
Okay.
columns. That's it. Okay, into fact.
Mm-hmm.
Okay, very simple.
Taking so long. And restore file like that error is coming.
I think it didn't open, right?
What?
Is the server open? Are it open?
No, it's not opening.
Have two servers there. So server 2015.
Yeah, but that is not going. I uninstall everything in that state. If I format it, it will go. It's taking too long. It's not opening.
Hmm, not opening. Try to restart your system once. Okay.
Okay.
You want me to wait?
Yeah.
Okay. Try to restart system. Yeah, yeah. Got it.
Yeah, yeah. It's open. Okay.
Okay. So right click on the database and go to restore database.
Database, restore database. Then from device.
Yeah, from device. And
Hmm.
find that backup file.
Yeah. This one.
Yeah, anything.
Adventure works dot back.
Take it out. Yeah. Take the AdventureWorks DW. Click on OK. Just click on OK.
Okay.
Okay. So go to two database and select database.
Hmm.
So check the
This one.
restore. Yeah. Check the restore. Okay. You need to check that option. So there is a restore name, right? Select the backup fields to restore.
So to a point in time in that I have to select anything.
So in the down, no need to select that. Come down there. You'll find
Yeah.
the restore. Okay. Check that. Yeah.
Yeah, that I did.
Click on OK.
Anything else?
That's it. Click on OK. Yeah. Got it.
Oh, yesterday I didn't do this. I didn't check.
Mm-hmm. Yeah. You need to
No.
check it. You need to check.
Restore of database completed successfully. Okay.
Same way, you can restore the data. AdventureWorks also.
So now where can we get this? In database?
Pardon me?
Okay. Over here, right?
Yeah. So AdventureWorks DW. You can check the tables. You will find the dimension tables in factor.
Yeah, got it. Yeah, so the problem was not because I didn't check it.
Yeah. Okay. And so on Monday, right? We are meeting on Monday.
Yeah, now on Monday.
Monday, we try to finish the triggers and
Okay.
some concepts are there. Okay, we try to finish them Monday and Tuesday. So from
Okay, no
Wednesday
problem.
onwards, we go for the MSB again. Okay,
MSBI.
and
Yeah.
then on by Saturday, I will send the queries to you. Okay, so
Okay,
try to work
no
on that.
problem. Yeah, yeah.
Yeah. Thank you. We see you on Monday.
Bye. Thank you.